Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Rocket Lab's Neutron rocket. So let's dive right into it. Now first, what exactly we are talking about? Basically, Neutron rocket development was announced very recently, meaning it was shared to the public on 2 December 2021. Before this, Electron rocket and Rocket Labs, they were operating as a private entity, meaning they had no affiliation with stock market, which changed recently. So now they have to be far more open about things if they want their stock value to go up. So they are announcing this sort of things. Like I think it's still a few years ahead, ahead of them, but they are like still announcing it's like, no, we are not sitting on our ass, we are actually working. So the tagline of whole scenario is very simple. It's like we are making a rocket of 2050 now, meaning a rocket that should have been made in 2050. We are trying to make that now. And aim of this puppy is basically very quick turnaround, meaning launch, land, reload, launch. And they should be able to make this puppy go around in 2 days, meaning launch, next day another launch. That's their aim point of it. So 24-hour system, which is very huge if they can pull it off. The turnaround part is very critical. Like every aspect of this rocket from day one is designed in such a way that they will not have lengthy turnarounds like Electron. Now Electron, when they started the company, they were like, yeah, we're not gonna make it reusable, but they have to make it reusable because cadence of space industry is going up, meaning launches are going from like once or twice a month to like multiple times a week. So the turnaround is the main target point there, and they are trying to achieve 8-ton class rocket. Now 8 ton may not sound very huge compared to Falcon 9, but you have to be mindful of that. They came up to this number by analyzing everything that was launched, and their data analysis said very simply, it's like if you have a rocket that can do 8 ton while landing to a launch site, and this is very clear, not landing on barge, landing on a launch site, you would cover majority of launches that has been done till this date, flat out. It was like, don't think about it, don't worry about it. It's like almost everything you can that is launched, you should be able to launch. So meaning the portion of market that you can cover with a rocket that can do 8 ton to low Earth orbit is much larger than you would think. You may think like, oh, everybody is building SLS, Falcon Heavy, or Starship, or Vulcan, big rockets. Does not mean every Dominican Harry needs that. So that's their aim point. Is like same way Electron is a very underpowered rocket, but here's the deal, they're still very successful. So because they are targeting a very niche market, here they are targeting broad market, meaning it's like if you do not need huge payload, why the heck waste money with SLS or things of that nature? Just come with our small rocket or Neutron rocket. So that's the idea behind it. They want to make the best option for 8-ton class system, meaning if you are launching any ton below 8 ton, they should be able to offer you a price that no other company should be able to compete against. Now, why they are doing this? Because fundamentally speaking, rocket takes long time to develop, and this company just recently started to launch Electron, and going from just starting to actually launch it, actually sending into orbit, actually starting to make profit is like, okay, let's make another version. Why? Well, reality is there are many cost, like amount of money that you have to spend are fixed regardless of the size of the rocket. Meaning if you are launching Electron, you are making does not matter. You are launching Proton rocket, still does not matter. Neutron still does not matter. Saturn V does not matter. These costs are fixed. There are many such costs in rocket industry. For example, permits, licenses, range safety, all these things have a fixed cost, meaning let's say per launch is costing you $1 million. Just go for that. It does not matter what's the size of the rocket. So that's why making a bigger rocket makes financial sense. And running cost of the company is also fixed, meaning how often do you have to pay your employee per month, for example. That's a fixed amount. Now think of it this way, let's say in that 1 month you are launching 5 satellites, then that's a good amount of profit. But what if you can launch 20 satellites or 30 satellites? That's GG amount of profit. That's the whole point. There are some significance of like very serious profit significance if you can make things faster, and more payload quickly provided, better revenue source. Even though this company wants to go into stock market, you never want to rely on stock market. Stock market should be added to you, not sole source company. It's like, okay, we had one bad day or bad PR, or like whole stock market. And not to mention, stock market is fundamentally volatile. It always goes up and then goes down, goes up and goes down. It's a fixed thing almost. So as a company, if you really want to be stable, you want to have a independent major income stream, and stock market to be like, it's just like, just letting some money in, just some extra money. So that's why they are doing this. Like any satellite launch provider that are only focusing on small rocket, they're gonna go bankrupt sooner or later. Even for launcher providers that are working in India, it's like they have to get a small rocket, they have to figure it out, they have to learn from it, and then they have to jump to basically medium size or large size rocket very quickly, meaning this is not sustainable in the long run. Your profit will start like lot of profit, and poof, So to make sure that you do not go poof, you have to do something like this. It's an important step. Now, what's the design behind it? Design it, they learned a lot when they tried to reuse electrons. Utilizing that knowledge and studying basically Falcon 9, they have the advantage of engineering's first rule, meaning you do it first or you do it better. So they want to do better. For example, the biggest flaw, quote unquote, not be mindful, it's flaw in a very loose sense simply because that's the best they could have done at that point in time, is Falcon 9 is way too slim. This is a normal size truck. Now, of course, not the bed behind it. The truck system is small size. It can be fitted into normal roads, and that was by design. SpaceX, when they were building Falcon 9, they did not have GG amounts of money which NASA had. So NASA has a huge space shuttle. They can carry it around huge roads, and they can literally regrade the road just so they can carry space shuttle there. SpaceX did not have that kind of money. For that reason, they had to make sure they comply within a regulation. That regulation made sure that their rocket would be very tiny. Now, consequence of that, it became way too long. That did add cost, but that was like very simple analysis on their part. It's like, if we cannot make it and we cannot ship it from point A to point B, we're gonna go be broke anyway. So let's try to make this work, and they successfully made it work. So diameter is a very significant consequence of this design. The first thing they're changing, diameter. The base diameter is 7 meter, which is huge, and even the fairing diameter is not a laughing matter. That is around 5 meter. It does taper off. So that's the biggest advantage they have. It's like bigger, fatter rocket, and it's shorter. Now that allows during re-entry much better control. So that's the first problem solved. Second, instead of utilizing grid fin, if you are familiar with the Falcon 9 development, they could not use steel simply because it was too heavy. They tried to use basically aluminum. It used to melt literally during re-entry. Many grid fins have melted. Then they started to use titanium. Now you're like, wait a minute, titanium is expensive. Yeah, duh. It's like they are using the world's largest single piece cast titanium. This is like very expensive. So that also they're like, yeah, titanium grid fins, take poof. And they're using canards. Canards are far cheaper compared to grid fins. And landing legs. Landing legs also took SpaceX a lot of time to develop. Here they have almost landing leg that is pre-built into the system, and they have landing foot, the foot that comes out and goes in. So it's very easy, very simple. Now, the engine they are developing is Archimedes engine. Now this puppy is running on liquid oxygen and methane. Now primary aspect of methane is that it does not create soot when burnt. So that should give them the idea of not having a rocket that becomes black. You rocket launch, it's white. When it's coming back to Earth, it's like turning black. Every launch you are turning it black, and that has consequences, not just cosmetic. You're destroying the engine because the soot created, it's very corrosive. Not corrosive would be correct word. It's like very destructive to the engine. So engine inherently has a lifespan limitation. You have to swap out engine. Even if the whole chassis is intact, you still have to swap out engines because the gunk in the gas generator will almost clog it up. So fundamentally using a cleaner fuel is desirable, and that's why Raptor does not use kerosene. So methane is used here. So you can understand that, like, they looked at Falcon 9. It's like, okay, you have solved so many problems. What are the things that are limiting you? First, skinny rocket. Okay, make it fat. Awesome. Grid fins are expensive. Let's make remove it. Let's put canard, super cheap. Landing legs. Okay, let's make it fixed. So that's what they are doing. And in terms of rocket engine, they are, even though they are using better advanced fuel, they are not using advanced cycle. They have open cycle gas generator. Benefit, it's simple. They can just like, lol, that engine is that simple compared to Raptor. Now if you have watched my recent videos or previous video on Rocket Monday, you know for a fact that Raptor manufacturing is a huge headache. And if it's a huge headache for some company as successful, as agile, as powerful, as smart as SpaceX, what the heck this company gonna happen to this company? So that they learned it very early on. It's like, do not try to make like, the best, most amazing engine out there. It's like, just make something that is feasible, easily manufacturable. And even in the presentation, they made one point very clear: we are not want to push it to like, every nut bolt breaks apart. It's like very gentle, very calm, very, it's like, we can reuse. It's like, don't think about too much about it. And they're gonna put only 7 in first stage. Now the reason why they have to only put, because it is a smaller rocket compared to in terms of total payload that it can throw into orbit, it is smaller. And each engine is a bit more powerful than the Merlin engine, not too much, but bit more powerful. And the first stage will have second stage will have 1 engine, and fairing is directly attached to stage 1. This is their unique innovation, because SpaceX did try to reuse fairings, and they have successfully managed to do that, but they have to make it splash down on ocean. It's not desirable, but they have figured out it's like they can deal with it. And given the fact that majority of SpaceX launches slowly becoming Starlink launches, they do not have any reservation on their own equipment. So they're like, yeah, we can deal with it. But this company is like, no. Many first, they are not planning to launch their own mega constellation. So they're like, yeah, we have to show the people, it's like, we are not using seawater loved equipments. So they have to make sure the fairings is directly attached to the first stage. So basically this first stage is complete height, and then they open it up, launch the second stage from the inside, and then it goes away. So that's the design element aspect of it. Now, what's the end game behind this? End game is very simple: reduce operational cost. Every Tom, Dick, and Harry knows this point. It must reduce operational cost. If you do not do that, the end your company starts with a little bit of profit and then goes poof. So the main aim they are doing is like making it reusable from day one. That's the same advantage that Starship has. It's like Starship from day one is like, we're gonna make it reusable rather than like, okay, trying to jam it into things, trying to use jet engines, which they did wanted to try. They did wanted to try jet engines and did wanted to try parachutes. They cancelled it. It's like it did not work out. But you have to understand that now the world has way too much experience with reusable system. Engineering's first rule: you make it first or you make it better. So now everybody knows that do not waste time on parachutes or things, especially for big systems. They'll just use the propulsive landing. So everybody is directly going for that and capture huge market share. This is the interesting part. That 8-ton is very precisely chosen. It's like, don't make it too big, don't make it too small. It's like, just make it good enough that every Tom, Dick, and Harry is like, yeah, I know at least 5-6 people who's gonna launch that rocket. Of course, in space industry, not every Tom, Dick, and Harry, but you get that point. It's like, of course, I'm not gonna be utilize this Electron or Neutron for like making giant space stations. But again, how often do you make giant space stations compared to how often you launch normal satellites? So that's the whole point. And it should, if it works properly, it should allow them to long lasting, because right now they have to drop their dollar per kilogram. While Electron is good, it is very lowest cost rocket, it per kilogram is not very good. What does that mean? That simply means Falcon 9 can bitch slap this. Falcon 9 during ride sharing can literally drop the price multiple times below this by almost a factor of 10. The only reason not everybody wants to use this ride sharing is it's ride sharing. You have to wait for a time slot to line up. If you want to do like repetitive, very quick, very iterative, it's desirable to use this. But then this creates a problem. This becomes a luxury service rather than a necessary service. Now think of it this way: let's say you are a college or university, you will not take a risk on this. You do not need that quote-unquote luxury, so you will use this. And imagine it this way: like SpaceX improves this pipeline properly, and they're like, dude, we are doing ride sharing properly. This company is gonna go poof. So they have to have a bigger rocket. And this will also give them the advantage. They can actually talk with big boys specifically being geostationary satellites. That's the big boys right now. So they want to talk with the big boys. Now, what's the timeline of these things? Well, be mindful, we are just looking at CG at this point. So it does look awesome, but I really don't think it's a very good idea, simply because it has way too much seams, meaning the places where you have to have latches. If I have to design it, I will try to do it with 2, because the number of latches that you have to have will go down, and the number of hinges will also go down. So that may be a desirable thing. 3 at most. 4 is too much. It does look cool, but it may be too vulnerable. Again, that's just my opinion, and let's see what they crack out to be. But be very mindful. What you are looking right now is just CG. They do not even have full built prototype yet, so they have to change a lot. It's expected. It's like it's a bit different compared to what other companies do, like ULA or things of that nature. But like when you pay attention to SpaceX animation and you look at their final product, it's like, dude, they do not match up. Same will happen here, because they are doing this more for like stock boost and more for like getting advanced booking and things of that nature. So do not expect it's like, oh, this is exactly the final product. This is just a rough idea. This is the idea they are working towards. It's like our finished product should look something like this, and they are working towards it. Could they make it a bit fatter in the bottom? Maybe. A bit similar, bit taller, whatever. Like the things could change. The canard size may go up. Things of that nature could happen. So be very mindful. Right now, all you have is CGI. And first engine testing should happen next year, as in 2022, mid 2022 if we are lucky. So 2024, I'm expecting them to be able to launch base rocket, meaning just the whole completely rocket, and they're launching it, sending stuff to orbit. However, reusability even after that will take some time. Reusing something in paper, computer is super easy, but like actually landing a rocket safely and reusing, because even if you did that in first try, you will not reuse that. You will like take it apart, study every single nut and bolt, every single joint, because again it is carbon fiber, so it is a bit difficult to like quote unquote patch it. So they have to study this. They may even require X-ray scanning the whole thing. So it will take some time. And human rating, this is their target. They do want to human rate this, but this is very difficult. Be mindful, SpaceX right now is the only private company that has human rating. The reason for that is that not only they have rocket that is basically human flight certified, they also have a capsule. And this company right now have not talked about any capsule. Of course, I'm pretty sure they are working behind the scenes on that. And after like 2-3 years, once they have like starting to finish this project, then they're like, we are also working on that. I'm pretty sure of that. But be mindful, it will take much longer than if they are saying that we're gonna get human rating in 4 years. I'm like, no, that will take much longer time. So be a bit calm about things. It will take time, and do not be surprised if you see a lot of things changed in the final product. So this was my presentation on Rocket Labs Neutron rocket. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I would urge you to press dislike. And I would urge you to please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.